name is Laxita. Today we are going to discuss a topic named motion in a straight line. As you can see, the title itself has two keywords. First motion and second is straight line. Let's talk about the first keyword. What is motion? Motion is nothing but change the position of an object with respect to time. But what is position? We don't know anything about it. How does the position change with time? So let's talk about position in this session. To know more about it, how to describe it, how to measure it, we need two things. First, a reference point, and second, a set of axes. You can see a picture in the slide. This is an example of a rectangular coordinate system, which is very important to describe the set of axes. Generally, we take three axes which are mutually perpendicular, and we name them x, y, and z axis. The point of intersection of these three axes is known as origin. We can use it as our reference point. In the slide you can see these axes are perpendicular to each other. Now we want to consider, or we want to calculate the position of an object which is placed at P. We need to find its coordinate. The distance from x-axis is x, y-axis is y, and z-axis is z. So the coordinates of P will be x, y, z, which are its position. If the point P, where our object is placed, is moving, the coordinates will be changing continuously. The second keyword, frame of reference. The event which is happening, which is like let's take an example of moving car. It can be described differently with respect to a different frame of reference. Let's say the car is moving on a road where you are just standing and watching the car moving from a point A to B, and your friend is sitting in a crowd. If we take the frame of reference which attaches to your friend, then the car will be at rest. But if we take a frame which is attached to you, the car will be in motion. Now we know about the coordinates and we know about the motions. Let's connect them. If one or more coordinates of an object change with time, we can say that the object is in motion or moving. If they don't change with time, the object will be at rest with respect to, note this frame of reference. Now we want to understand the types of the motion, which are one-dimensional, two-dimensional, and three-dimensional motion. To describe one-dimensional motion, we need one axis. Generally, we take x-axis. To describe two-dimensional motion, we need two axes, means a pair of axes, x and y. For three-dimensional motion, we need three axes, x, y, and z axes. You can see three animation, which is one-dimensional motion, two-dimensional motion, and three-dimensional motion. In one-dimensional motion, the guy is moving on a road. In second animation, the two-dimensional motion, the guy is throwing a ball in the trajectory. And in the third animation, you can see a point x, y, z. The coordinates of the point are x, y, z, which are in the three-dimensional. Now we want to learn about the moving car or object in just one-dimensional motion. The object may be stationary or moving, so we can calculate its position easily with these steps. First, we need to know about the path of the moving or stationary object. Second, we need to find an axis which coincide with the same path, and then we are going to need our reference point. We are going to choose an origin O in the same path or axis. Third, position to the right of R are taken as positive and the left are negative. Let's take an example of Q. It is at 240, but it's on the right of the O, means Q will be positive, and R, which is on the left side of O, will be negative. This is everything you need to know about the position. Thank you for watching this. These are my references which I study. And if you have any doubts and suggestions, reach out to me at this Gmail. Thank you.